Fires are a major cause of forest degradation and have wide-ranging adverse ecological, economic, and social impacts, including loss of valuable timber resources. As a team of engineers, we came up with an innovative idea to track and predict the forest fires using drone mapping technology, which incorporates embedded systems, image processing, and communication systems. A drone with all the features we have proposed doesn't exist. A very close competitor to our product is the fire detector drone by the Carlos III University Madrid. Further updates on their implementation is not available. Though there are drones that have a few of our features individually, like there are drones that auto lands and a few ones that auto charge, and a few drones built exclusively to detect fire. None of them providing an entire coverage of features like auto landing, fire detection, and informing the concerned authorities about it totally. The project handles multiple features on drones. It consists of image processing, advanced drone mechanics, which on development has features like auto landing, self charging, and as a next phase, we intend to add machine learning algorithm to image processing to predict the occurrence of the fire. These features are in scale of the current technologies and can be easily constructed once a basic functioning prototype is ready.
We had ideated this drone as a venture to support authorities involved in fire and disaster management. Hence, converting the idea to a venture was not difficult in the initial state. We had evident shortages in funds as the components for the technology used was expensive. Despite the troubles of being beginners in the field, we managed to develop many intricate features such as fire detection using image processing, establishing communication, and building a drone. The prototype involves the use of high-performance embedded system BeagleBone Black, a low-power module MSP430, and a very small size LoRa used as the communication system, which are interfaced with both MSP and the BBB. Integration is the key differentiating factor. All the existing solution lacks some feature or the other. We have tried to include all the required features and also make use of a wide range of technology. These include advanced drone features like self-charging, auto-landing drones, also thermal mapping and AI-generated predictions to monitor the forest fire is quite an innovative approach to the existing solutions. In addition to these, we thought of communicating the presence of fire when detected to the authorities. Detecting fire by means of just atmospheric values aren't totally reliable. In addition to the sensors which calculate atmospheric conditions such as humidity and temperature, the use of image processing will give much better results for detecting fire. Humans can always patrol every corner of area of interest, and also it isn't safe to do this task. Employing drones will reduce manual labor cost, at the same time increase efficiency and help patrol more areas in much lesser time. Using wireless communication provide means to relay the message very cheaply, fairly fast and efficiently at the same time. Wireless technology is the most feasible option given the damage fire could cause to the wired communication. To the range of engineering fields that the project incorporates and the impact that the product can have to contribute to saving nature when implemented at full capacity. The idea has a very high potential to be implemented on large scale. With the responsible use of resources and funding, the existing prototype has a huge market potential.
The components we have interfaced so far are the BeagleBone Black, MSP430, LoRa, and the USB webcam. The TI components we have interfaced are the BeagleBone Black and MSP430 FR6989 Launchpad. The BeagleBone Black is used for processing input images from the camera and detect fire and send the alert messages via the LoRa module. The MSP430 is used at the receiver end to receive the messages transmitted by the BeagleBone Black and the LoRa module. The non-TI components interfaced are the LoRa and the USB webcam module. The LoRa module is used at the transmitter and the receiver end for transmission and reception of the alert messages. The USB webcam module is used to capture images of the area to detect the presence of fire. The BeagleBone Black is the central system to control the input video and process to find out the potential of a fire and then to alert the authorities via a signal as output using LoRa, hence making use of the embedded processing and connectivity by means of LoRa interfacing. The MSP430 is used at the receiver end to take in the incoming signal by means of LoRa, therefore establishing connectivity by means of the LoRa module. The alert is displayed on the LCD interface on the MSP, hence making use of the embedded processing on the MSP.
The verification and validation of the prototype can be performed by setting up a fire, a very small one, and using the webcam attached to the BeagleBone Black to detect this using the image processing mechanisms implemented.
Roadblocks and resolutions. Due to the pandemic, the team was unable to physically meet and work hands-on on the project. But nonetheless, we held virtual discussions to proceed with the project and sorted out ways to complete it as per schedule. Components were exchanged as possible and new components were acquired once the product delivery mechanisms were back in place. Perseverance, proactiveness showcase. We had been keenly working on it despite the hurdles we faced. We also acquired monetary help from the entrepreneurship cell of the college, with which we were able to resume with the rest of the project. Setting up of the LoRa by giving it connections were done using the equipments in the college laboratory as and when the college reopened. In our efforts to learn the basics of drone and get a feel for it before moving on to bigger drones, we had built a small one at a workshop literally just 2 days before lockdown. This is a demo of the drone.
Considering the case of a fire, a USB camera module captures images or streams of images, say video, and sends it to the BeagleBone Black. We've used OpenCV so that in case of a trigger, in our case, in case of a fire, an emergency message is displayed on the onboard LCD screen of the MSP430 FR6989 launchpad, which is triggered by the GPIO.
Thereafter, the pins to the LoRa device were soldered using a fine-tip soldering iron which was available in our college. This was done as soon as the college reopened after the pandemic lockdowns.
This shows a simultaneous connection of the LoRa to the MSP and another LoRa to the BeagleBone Black. Upon running the program, it shows the key. If it is calm, then it is 0. The LoRa receiver shows 0. In case the input is 1, that is if fire is detected, then the LoRa receiver 2 shows 1, which will be seen in the serial monitor.